Have you ever driven over a bridge and felt a slight bump or noticed a rusty streak running down the concrete? You might just write it off as normal wear and tear. But what if I told you that bump is a symptom of a much larger, much more dangerous problem? A problem that's slowly eating away at the bones of our country. This isn't just about a few potholes. This is about the real reason why America's bridges keep failing. It's not always a dramatic, sudden collapse like the ones you see in disaster movies. More often, it's a slow, silent decay. An invisible killer that engineers call concrete cancer. It starts deep inside the structure, where steel rebar, the skeleton of the bridge, begins to rust. As it rusts, it expands, cracking the concrete from the inside out, weakening the entire structure until it can no longer support the weight it was designed to carry. And it's happening on thousands of bridges across the United States right now. So why is this happening? To understand, we have to go back to the 1950s, the golden age of American infrastructure. The creation of the interstate highway system was one of the most ambitious engineering projects in human history. We built thousands of bridges fast. They were symbols of progress, connecting the nation like never before. But here's the catch. They were built with a lifespan of about 50 years. Well, do the math. We are living on borrowed time. The core of the problem is something called deferred maintenance. Think of it like this. You know you need to change the oil in your car, but you put it off. For a while, it's fine. But eventually, the engine seizes up, and you're left with a catastrophic failure and a massive repair bill. That's what's happening to our bridges, but on a trillion-dollar scale. For decades, funding for inspection and repair has been kicked down the road. Small problems, like a clogged drain that lets water pool on the deck, are ignored. That water, often full of corrosive road salt from winter de-icing, seeps into tiny cracks. It finds the steel rebar and the cancer begins to grow. Now, you might be thinking, can't we just build better bridges? And we can. Look at the Romans. Their concrete structures, like the Pantheon, have stood for 2,000 years. Their secret was a unique mix using volcanic ash that actually grew stronger over time when exposed to water. Modern concrete is different. It's strong and cures quickly, which is great for building fast. But it's more brittle and susceptible to this internal decay. We traded longevity for speed, and now we're paying the price. And it's not just age and materials. Our bridges are facing threats their designers never imagined. The first is weight. The number of heavy trucks on our roads has skyrocketed, and they've gotten much, much heavier. A single 80,000-pound truck can cause the same amount of wear as thousands of cars. When these heavyweights cross a bridge day after day, year after year, they create tiny stress fractures, accelerating the aging process exponentially. It's like a boxer taking thousands of body blows. Eventually, the internal damage becomes too much. The second new threat is climate change. More intense rainstorms and flooding are causing a phenomenon called scour. This is when fast-moving water literally eats away the soil and rock from around the base of a bridge's support piers. You can have a perfectly healthy bridge structure, but if its foundations are washed away, it doesn't matter. It will collapse. We're seeing this happen more and more as 100-year floods become 10-year events. Our old infrastructure simply wasn't designed for this new, more violent weather. So what are we doing about it? The good news is, engineers are fighting back with incredible technology. Drones are now flying into the tight, dangerous spaces inside bridges to inspect for cracks, using thermal cameras to spot hidden water damage. Divers are performing complex underwater welding to repair scour-damaged piers. In some cases, they're using advanced composite materials, like carbon fiber wraps, to strengthen weakened concrete columns, essentially putting a high-tech cast on a broken bone. There are even massive mind-boggling projects where engineers will literally lift an entire bridge deck a few inches to replace the old bearings, all while thousands of cars continue to drive over it completely unaware of the surgery happening just beneath their wheels. They use arrays of synchronized hydraulic jacks, all controlled by a central computer, to make sure the lift is perfectly even. It's a nerve-wracking, high-stakes operation where one mistake could be disastrous. But these high-tech fixes are expensive, and we have over 46,000 bridges in the US that are rated as structurally deficient. We can't just patch our way out of this problem forever. That's why some cities are making a radical choice. They're not repairing old freeways, they're removing them entirely. They're realizing that these massive structures from a bygone era divided communities and that replacing them with boulevards and parks can actually create a better, more livable city. The state of our bridges is a reflection of our national priorities. They are the arteries of our economy and the lifelines of our communities. For too long, we've taken them for granted, ignoring the slow decay happening right under our feet. The next time you drive over a bridge, take a moment to look. Look at the joints, the concrete, the steel. It's not just a structure. It's a story of ambition, neglect, and the constant, hidden battle between human engineering and the forces of nature. And it's a story whose next chapter we are all responsible for writing. Thanks for watching. If you found this interesting, consider subscribing for more deep dives into the engineering that shapes our world. See you next time.